Welcome to our second section in Algebra 2. This is actually section 1.3, which we are studying solving linear equations. Anytime we are trying to solve an equation, we are trying to get a variable by itself. That variable is generally going to be x, and we are trying to figure out what x is equal to that would make the equation a true statement. Before we do that, let's kind of revisit something from something that we studied in the past. When we're talking about trying to do math, we do have an order for what I put in quotes here, doing math. That order should be well known to you guys, and that order is PEMDAS. I do want to make a point to say that when we talk about PEMDAS, we always have multiplication before division and addition before subtraction because that makes this acronym work. But in actuality, multiplication and division are tied for like which one would happen first. And we do those from left to right. And the same thing for addition and subtraction. They should be written like this, addition or subtraction, and we do them in order from left to right. It's not that addition takes preference over subtraction. Whichever one is further to the left would take preference over the other. So you might see a question that looks kind of like this. I just have you do some math, right? We got some operations going on, and you have to make sure you do this in the correct order in order to ensure that you get the right answer. Step one, or the first thing you try to do is simplify any parentheses. We do have some parentheses that we can simplify here. We know 2 minus 1 is 1, so we'd have 3 times 1 plus 2 squared. Up next in the order of operations after parentheses would be exponents for the e. We do have an exponent here, so 2 squared, we'd get 4. We'd have 3 times 1 plus 4. Then we would do multiplication in order from left to right. Well, there's only one multiplication in there, or multiplication slash division in there. We'd end up with 3 plus 4, and we know 3 plus 4 is 7. You should, like I said, and I would verify this just to make sure that you're using your calculator correctly, you should be able to type these into a TI-83 or 84 or any graphing calculator and be able to ensure that you get the right answer of 7. If you're not, we need to talk about that and make sure that we are able to get that answer. We already went through these problems in the first lecture video, 1.1, 1.2. So the order for which we do math, right? We have operations and we want to just find out what it equals. That's PEMDAS. But we're also going to spend a lot of our time undoing math. And what I mean when I say undoing math is that we are trying to undo things in order to solve for a variable. We are trying to get that variable by itself. And the order by which we're going to do this is not PEMDAS. We're not going to prioritize parentheses and then exponents. We're actually going to do this in the reverse order. You're first going to look to undo subtraction or addition. And this should all be reviewed to you guys, this process of solving equations. And it actually should be even review in Algebra 1, but we're going to still spend a lesson on this and make sure that we are all on the same page because we're going to be solving different types of equations throughout Algebra 2. Today it's linear equations, but we are going to study multiple different types of equations throughout the year. And the process by which we're going to solve them is going to look a little bit different in every section. So it's important that we understand these concepts really well so that we can be effective, we can be good at the other types of solving equations. So like I said, what you want to do is solve for x. You want to get x by itself. You want to get rid of the other stuff. So what you do is you look and you say, okay, x is over here, but it's got some other things going on with it. It's not by itself right now. It has a plus 8, and it's also being multiplied by 4/5. Now, the way that we're going to decide what we're going to undo first is we're first going to look for subtraction or addition to undo, and we do have a plus 8 here. And in order to undo it, we're going to do the opposite of add 8. And the opposite of adding 8 would be to subtract 8. The computer is being a little glitchy here. Sorry, I don't know what the deal is. And if you subtract 8 on one side, you also have to subtract 8 on the other side. Okay. So 20 minus 8 is 12. Plus 8 and subtract 8 cancel each other out, and you're going to end up with 4/5. X is equal to 12. Now, this is going to be digging back to previous years. How do you undo multiply by 4/5, right? That's what's happening to x. X is being multiplied by 4/5. We need to undo that. And so the way that you're going to undo 4/5, we say is multiply by its reciprocal, which is the flip of the fraction, right? 4/5 reciprocal would be 5/4. And if you do it to one side, you also have to do it to the other side. So we're going to multiply this side by 5/4. This actually goes back to the first lecture. We talked about what happens when you multiply by its reciprocal, that is the identity. It cancels out to 1, or the inverse, sorry. It's the inverse, and it cancels out to 1. So 5/4 and 4/5 undo each other. And you're left with x is equal to whatever 12 times 5/4 is. We should be able to type this into our calculator as well. 12 times 5/4 is 15. So it's a good habit to get into when you arrive at your answer to double check it, make sure it actually works. So if you took 15 and you plugged it in for x, 4/5 times 15 is 12, and 12 plus 8 is 20, and we are correct. We know that because 20 is equal to 20. So we should be able to do this pretty consistently, pretty effectively. 4x minus 2 equals 12. We should know that we would undo addition or subtraction first. There is a minus 2 here, and the way to undo minus 2 would be to add 2. And if we do it to one side, we have to do it to the other. Minus 2 and plus 2 cancels. Those are inverses of each other. And you get 4x is equal to 14. Now our x is being multiplied by 4. The way to undo multiply by 4 is to divide by 4. Those are inverses of each other. They're going to cancel each other out. If you divide by 4 on one side, you have to divide by 4 on the other side. The 4 and the 4 here, multiply by 4, divide by 4, they cancel. So you just have an x is equal to 14/4. Now, this is a fraction that can be reduced. And if you do not reduce your fraction, you will be getting partial points taken off. With your graphing calculators, we can go over this in person, but the calculator command on a TI-83 or TI-84 would be to do 14 just divided by 4, and that should give you a decimal. But if you push the math button, yes, there is a math button on a graphing calculator. The top one, I believe, says frac. And so then push enter, and it should reduce that fraction. But you guys should also know that 14/4 does reduce to 7/2 because they're both divisible by 2. You could divide them each by 2. Now this question is different than the last set because the variable is on both sides, right? There's a p over here and a p over there, and we need to solve for that variable. So we need to get them on the same side of the equation. That's going to be something that we kind of prioritize. Well, if there's a variable on one side and a variable on the other side, let's get them to the same side, and then we can proceed. So like I said, this is something you guys have seen before, so we should be able to do this, but just kind of as a refresher, we want to bring the variables to the same side. If I have a 7p over here, I can undo 7p by subtracting 7p. 7p minus 7p is 0, right? You cancel each other out. If I do it on one side, I have to do it on the other side. Those cancel. We're going to get 13 is equal to 2p minus 5. And I'm going to solve this. This is now just like the previous slide, right? The previous type of question. 2p minus 5. I need to undo this, solve for the variable. It's got to multiply by 2 and to subtract 5. We would undo the subtract 5 first, so we would add 5 to both sides. We're going to get 18 is equal to 2p, so p is equal to 9. Like I did state earlier, it's a really good idea to get in the habit of taking this number and plugging it in and make sure that we are getting two sides that are equal to each other. There are going to be problems this year that's essentially a requirement. It's something you're going to have to do because weird things are going to start to happen. So it's a good habit to get into. Just plug it in, make sure it works. It should only take you a matter of seconds. Go ahead and pause it. Make sure you get this one. And then push play, and you can follow along. So once again, we got the same, we got a variable on both sides of the equation. We have a 2p over here and a negative 4p over here. I'm going to move this negative 4p to the other side. The way you move a negative 4p would be to add 4p. If you do it to one side, you have to do it to the other. So we would end up with whatever 2p plus 4p is. Of course, that's 6p plus 7 is equal to negative 5. Once again, we are trying to solve for our variable. So I'm going to move this plus 7 to the other side by subtracting 7. Negative 5 minus 7 is equal to negative 12. If you're really bad at this mental math stuff, your calculator will always be available for you to use. Okay, there is not a quiz or a test this year, but I'm going to say you cannot use your calculator. So just, you are allowed to use it. And that would be 6p is equal to negative 12. Of course, you divide each side by 6 and get p is equal to negative 2. Once again, we could check that, and that would be a good thing to do. There is some sections in, there's some problems in this section where you have more complicated equations and you still are expected to solve them. Just take it step by step. As I say here, basically you got two sides of an equation, right? Simplify this side as much as you possibly can, as well as simplify this side as much as you can. Once you're there, then move all the variables to one side or the other, and all the constants, the ones that don't have the variable, to the other side, and solve. So first thing, simplify the left side of the equation as much as you can, and the right side as much as you can. So I'm going to start by distributing this 3. That would give me 15x, right? 3 times 5 is 15, 15x. And multiplying 3 times negative 8, that would be minus 20. We also have a distributive property over here. Remember the distributive properties from the last section we talked about. You take the number up front and you apply it to both things. Negative 2 times negative x, we could put a negative 1 there if we wanted to. Negative 2 times negative 1 is positive 2. And there's the 1x. Negative 2 times 7 would be negative 14. So that's distributing negative 2. There's also this minus 12x over here. On the left side, we only have an x and a constant, right? A variable term and a constant term. But on the right side, we have 2 that have the variable. And some students do screw this up, so I kind of want to highlight it. Some people are like, well, in order to move this 12x, you would add 12x. Then you would add 12x here. Right? Do you guys see what I'm saying here? When you move something, you do the opposite. Keep in mind that when you move something to the other side of the equation, that's when you do the opposite. When they're on the same side of the equation, then you don't do the opposite, you just combine them. So you have 2x's over here, and you have negative 12x over here. To combine those, 2x and negative 12x, that would just be negative 10x, because the 2 and the negative 12, you can do 2 minus 12 and get negative 10x. And now is when you're going to go to moving things to the opposite side of the equal sign, and that's when you do the inverse, right? So I have a negative 10x over here. In order to move a negative 10x, I'm going to add 10x. If you do it to one side, you have to do it to the other side. So we have 25x, right, when you add those two things, minus 24 equals, those cancel, negative 14. Carry on, we get 25x is equal to, you add 24 here, you add 24 on one side, you have to add 24 to the other side. You get 25x is equal to 10. Now what's happening to x? X is being multiplied by 25. To undo multiplied by 25, you have to divide by 25. And when you do it to one side, you have to do it to the other. Those cancel, and you get x is equal to whatever 10 over 25 is. Now we can type that into our calculator. 10 divided by 25. When you push enter, you're going to get a decimal, but remember, Mr. Nyquist doesn't like decimals. What I would like you to do is turn that into a reduced fraction. The way to reduce a fraction is to push math on your calculator and then graph. That will automatically reduce it. 10 over 25 is 2/5. You should be able to do that in your head as well, noticing that both the numerator and denominator are divisible by 5. So divide both by 5. You get 2/5. We got one more to go. Go ahead and pause it here, give it a try, see how you do, and then we'll go over it. So we got a lot of distributive property here. Again, we have the numbers in front of the parentheses. Here it's a 3. We got to multiply it by both. So 3 times 2x would be 6x, and 3 times negative 5 would be minus 15. This negative x is just going to carry down. Here you have a negative 7, and that negative 7 needs to get multiplied by both. So you have negative 7x minus 21. Now we have x's on, we got a couple x's over here. We have this guy and this guy. We need to combine those. So a 6x and a negative x would combine to be 5x minus 15. And that's equal to negative 7x minus 21. Now get the x's on both sides, or the x's are on both sides. We want them to be on the same side. So over here, you're going to add 7x to both sides. That would be 12x minus 15 is equal to negative 21. Here's the x we're trying to solve for. Add 15 here to get rid of it. If you do it to one side, you have to do it to the other. 12x is equal to negative 6. So x is equal to negative 1/2. This is section 1.3. Check Schoology for what you need to do next.